All right. As I mentioned earlier, I was going to work through a guided projectile motion problem, one of the tougher ones, so you can kind of see how all the different parts work. All right, so here we have a ball is launched at 15 meters per second, 37 degrees above the horizontal. So we're shooting it up at an angle from the top of a 15-meter tower. Okay, so we've got some All right, so this is basically what we have. We have a 15-meter tall tower, and we're shooting at an angle of 37 degrees above the horizontal out at 15 meters per second. Okay, so this is a more complicated projectile motion problem because instead of launching it just horizontally, we have an angle, meaning we're going to have to split our vector into components. Okay, so this angle here will give us a Vx, and here will give us a Vy. So in every projectile motion problem, you always want to start by splitting everything into x and y. That's the best place to start with a problem like this. So in the x direction, we're going to have Vx. Okay, so we're going to break this into components to find the x component. X is adjacent to the 37, so it's going to be cos. So 15 cos 37, which gives us 11.9795 meters per second going to the right. Okay. In the x direction, because we're not dealing with air resistance, there's nothing to speed it up or slow it down. So we have uniform motion here, meaning we'll be looking for dx, and we'll need time to do it. Okay. For the y side of the equation, okay, Vy1, because in the y side, there is acceleration due to gravity, meaning we're going to have a Vy1 and a Vy2. So Vy1, Vy is opposite to the angle with the hypotenuse, so it's going to be sine. So 15 sine of 37, which gives us 9.0272 meters per second up. Okay. Our object is accelerating. Okay. It's experiencing the acceleration due to gravity, so 9.8 meters per second squared down. And we know that it starts 15 meters up and it ends up on the ground. So our displacement in the y direction is going to be 15 meters down. Okay. So in part A, how far does the ball travel horizontally before it lands? So we're looking for dx, right? This is the quantity that we are trying to find. So in order to find dx, we're going to need time. So in order to find time, we're going to have to find it on this side. So there are two ways to find the time. Okay? So the first is to use the equation that has dy, ay, vy1, and t. So delta dy equals vy1 delta t plus 1/2 ay delta t squared. So we can use this equation to find time. But you'll notice we have t and t squared. So that's like x and x squared, meaning this is a quadratic. If in order to solve this equation for time, you're going to have to use the quadratic equation, right? So you can set this up by plugging that in here. So I'm going to say up is positive, down is negative. Okay, so 15 meters down, so negative 15 equals 9.0272 delta t plus 1/2 times 9.8. It's going to be negative 4.9 delta t squared. Okay, so we can rearrange this equation. Okay, to get 0. So we can rearrange that equation to get 0 equals negative 4.9 delta t squared plus 9.0272 delta t plus 15, right? When you take the negative 15, bring it over to the right, we become positive, right? So if we were to plug this into the quadratic equation, this would be A, B, and C. Okay, so you can use the quadratic equation there to find the answer. If you don't want to use the quadratic equation, there is an alternative way that we can find this value. And to do that, we're going to find the other number that we don't know, which is VY2. Okay, so we can use that in the quadratic equation. Okay. And it basically just comes down to preference. So you've probably had practice with the quadratic equation before. I'm going to show you how to find it without the quadratic equation. And it'll also be helpful because it'll give us VY2, which we're going to need for part B. So I'm going to use VY2 squared equals VY1 squared plus 2A delta D. Okay. So if I use this here, VY2 squared, so I have 9.0272 squared plus 2 times negative 9.8 times negative 15. So VY2 squared, okay, is going to be 375.4903. Okay, I take the square root of that, and I get 19.3776 meters per second. Now, whenever you take the square root of something, the answer is technically plus or minus, meaning this could be positive or negative. So basically, we just look at the context of the question to see whether it should be going up or down. If you think about it, we launched it, it was going up. At the end, when it's coming down, right, VY2 is going to be in the downward direction. So we would give it the downward symbol. Okay. Now that we have VY2, we can use the following equation. VY2 equals VY1 plus A delta t, and we can figure out what the time is. So we have negative 19.3776 equals 9.0272 minus 9.8 delta t. Okay, so we move this 9.0272 to the other side, and we get negative 28.4048 equals negative 9.8 delta t. So we divide that through, and we get that time is 2.8984 seconds. Okay. Now, if you ran it through the quadratic equation, you'll get two answers, okay? One of which will be negative, and we ignore it because you can't have negative time. And the other one will also be 2.8984. So you'll get the same answer for time regardless of which way you do it. But you need to make sure that you're carrying 4 decimal places through, right? If we round this off to 9 and like we rounded this answer off, then we're not going to get the same answer that we would get from the quadratic equation. So in order for multiple methods to give the same answer, we need to make sure we have those 4 decimal places of accuracy. Okay, now that we have the time, this is an easy question to finish off, okay? Because in the x direction, okay, we have no acceleration, so we get to use the easy equation of Vx equals dx over t. So we have 11.9795 equals delta dx over 2.8984. And when we run that through our calculator for dx, okay, we are going to get 34.7 meters to the right. Okay. And this one I rounded to significant digits. Okay. 1, 2, 3, 1, 2, 3. So 3 significant digits. Okay? So that gives us our final answer. Okay? Because this is a final answer, I rounded it off instead of taking 4 decimal places. Okay? So that's quite a lot of work there, but we are able to get the end result. So it's the same kind of math you've done before, right? We set things up in X and Y, but we have to start by taking components. We break the angled velocity into an X and a Y, and then we have to solve. Because Vy1 is a value instead of 0, like in a horizontal launch, okay, the math is harder. So there's 2 ways to do it. We either use the quadratic equation to get the time, and then we can get the same answer down here, Vx equals dx over t. Or instead of using the quadratic equation, we find Vy2, and we use Vy2 in a different kinematics equation to find time. Okay, both of these get you the right answer. It's completely up to you which one works better for you. Okay, so the last part of this question is, what is the impact velocity of the ball? So it got launched at 15 meters per second. The impact velocity is how fast it's going the moment it hits the ground. So a common misconception here is that the impact velocity is 0. The impact velocity is actually the fastest the ball is going to be moving. Okay? So it comes crashing down. The moment that it hits the ground is the fastest that it's moving. After that, the moments after is when it hits the ground, bounces, stops moving. The ground might cave in if it's a heavy enough object. Okay, energy is transformed. But that moment that it hits the ground, that very, very exact moment, that's the fastest it's moving. It's the moments after that it'll stop and it'll bounce and it'll eventually stop moving. So the impact velocity is never going to be 0. The moments after impact is when it will eventually slow down to a stop. But that's just a really common misconception that common error you don't want to make. So what we need for this one is basically we're going to we have Vx, okay, and we have Vy2, right? And when we put these together, okay, this will give us our V2 vector, okay, whatever it's going to be. So we're basically doing the opposite of what we did at the start. At the start, we had a V1 vector, and we split it into X and Y. What we're going to do is we're going to take Vx2 and Vy2, and we're going to combine them to get Vy2. So we're basically going to do what we did at the start and kind of reverse it to put it back into a vector. Okay. There is no acceleration in the x direction, so Vx is Vx1 is Vx2. So this is our value for Vx. And Vy2, right, we just found is 19.3776, right? So Vx2 is the same as, Vx1, which is just Vx. And we already learned that it was 11.9795 meters per second to the right. And Vy2, which we just found previously, okay, was 19.3776 meters per second going down. Now, if you use the quadratic equation to find time, then you would need to still do this calculation in part B in order to find Vy2. So that's kind of why I did this method, because it got us the right answer, but it also gave us a number that we're going to need anyways. Okay. So now this is just basic, taking a horizontal and a vertical and assembling it into a vector. So this is just simple Pythagorean theorem at this point. So V2 is going to be 11.9795 squared plus 19.3776 squared rooted. Okay, so we're just using Pythagorean theorem here. Okay. And we're going to get 22.7816. Okay. We also need to find the angle. right? Tan theta is going to be Vy2 over Vx2. So theta is going to be the inverse tan of 19.3776 over 11.9795, which gives us an angle of approximately 58.3 degrees. So our final answer, rounded to 3 significant digits, is going to be V2 is 22.8 meters per second, 58.3 degrees below the horizontal. So we didn't have north, south, east, or west, right? We had going right and down. So we just frame it as below the horizontal. Similar to when we launched it, it was above the horizontal. Okay, so that is our final answer. Okay. So that's how these work. So in order to deal with a ball that's launched or not projectile that's launched at an angle, at a height, okay, we're going to have to make use of the either the quadratic equation, or we're going to have to find Vy2 and use Vy2 to find the time, so we can use the time on the x side to get what we actually wanted. Okay. If a question asks you to find the impact velocity, okay, impact velocity is going to be Vx, whatever you found for Vx. So, right, because Vx2 is Vx1 is Vx because there's no acceleration, so it's just constant in the horizontal direction. Vy2, right, the number going up and down. Okay, we put those together, we assemble a single vector, and that will give us the impact velocity. So the speed with which it hits the ground. Okay, hopefully that was helpful. Again, if you have any questions, make sure to send me an email.